What's up you guys? Now in today's video we are going to be covering chapter 1.1, which is composite function, right? So without further ado, let us get started. So the first thing we're going to learn is to determine composite function. What is composite function? So let me give you an example. Let's say you have two sets here. So this is set X, this is set Y. Okay, so here you have the object, which is X, and let's say here I have 2X, right? So the link between the object here and the image is the object, and the image is the function. So I can put as F, I can put as G, it's up to you. Okay, what you can use any label for the function. Okay, so set X links to set Y through this thing called the function F. Okay, so this is just one function. What if you have multiple functions? What if you have another set here, which is set Z? Okay, so let's say this one links here, becomes say 8x, let's say. Okay, so I name this as G. Okay, so this is another function. So when you combine, right, because this is two separate functions, one is through F function, one is through G function. Okay, but once you combine this, you call it composite function. So from object X goes all the way to 8x. So what is the composite function? The composite function is, instead of writing FG, which most people will write, which is incorrect, the proper way to write this is called GFX. Okay, this is what we call as the composite function. Although object is going through F and then it goes through G for it to achieve this, but when you are writing the composite function, you have to write the Fx in front, only then you write the Gx, right? So you get GFX. Okay, so what does this mean? It means that you are substituting Fx into Gx. Okay, so let me go through some examples and you guys can understand this composite function. All right, so question number 1, in the arrow diagram on the right, function F maps set P to set Q. Okay, set P to set Q, which is function F, and then function G maps set Q to set R. So number 1, determine what is function F. So function F, obviously it says here maps P to Q, correct? So P to Q is from X all the way to 3X. So in other words, when the object is X, okay, this is the object, when the object is X, it becomes, the image is 3X. Okay, so this is the function of F. Okay, what about function GF? Right, I told you before, when we say GF, it actually means you're going from X all the way here. Okay, so the composite function, instead of FG, you say GFX, right? It's like the other way around. Okay, so GFX. So what is the function of GFX? Well, it is stated here, right? 2x minus 7. So when the object is X, it becomes, the image becomes 2x minus 7. So GFX is equals to 2x minus 7. So that is the first question, right? Let us look at the second question. So given that fx is equals to ax plus b and f square x is equals to 4x minus 9, find the value of constants a and b. So they have given you the basic function. The basic function is fx equals to ax plus b. So f square x is what? What is fx? What is f square x? It means it represents ffx. Okay, ffx, that means there's 2x. Okay, so this does not mean multiply. Okay, this is not multiply. You cannot do this, right? You're not allowed to do this. No, this is wrong. Okay, you cannot multiply. This does not mean multiply. What does this actually mean is that you are substituting the fx value, which is the front one here. This becomes the object, and you're going to substitute this into this function, right, which is the same function. Okay, so to give you guys, let you all see what is actually happening. You know that fx is ax plus b, correct? You're going to substitute the fx into another fx. So you know fx is going to be, ax plus b, right? That is the fx. Now you're going to substitute this into the as the object of fx. So you're going to change this value, the x, you're going to make it another ax plus b. So this is what it means by substituting the fx, which is this, as the object of the new the fx, which is in front. Alright, so you substitute this as the object of ax plus b, so you get this. So next thing you're going to do is you're going to expand. So you're going to get a square x plus ab plus b, right? So this is fx. So what do you notice here? You know that f(x) is equals to a square x plus ab plus b, and they gave you f square x as 4x minus 9. So now you have two equations. This is the first equation, this is the second equation. So you're going to compare. So what can you compare? Well, you notice that there's one x here, there's one x here, correct? So in other words, I can say that this value is equals to this. So a square is equals to 4. Okay, so what is a? A is going to be square root of 4. So you're going to get two values because it's plus minus. You're going to get plus minus 2. Okay, it can be a positive 2. It can also be a negative 2. So now you're going to compare this now at the back. So ab plus b is going to be equals to negative 9. Okay, so you're going to get like this. ab plus b is equals to negative 9. Now the thing is, you have two values of a. So you're going to get two values of b as well. Okay, so if a is equals to positive 2, what are you going to get? So 2b plus b equals to negative 9. 3b is equals to negative 9. So b is going to be equals to negative 3. Okay, so you already got. So if a is positive 2, b is negative 3. But what if a is negative 2? So you're going to get negative 2b plus b equals to negative 9. So you get negative b equals to negative 9. So b is equals to 9. Right? Now let's see the next question. If fx is equals to 3x plus k and gx is equals to 2h minus 3x, such that fg is equals to gf, find the relation between h and k. So from here, they've already given you the relationship, right? The equation here. So you have to find the relationship between h and k. That's what they want you to find. So in this case, you have to first find this fg. So what does fg means? It means you are substituting gx as the object for f. Okay, so fx is what? 3x plus k, correct? But in this case, what, the x is not x anymore. It is going to be gx. So what is gx? So gx is going to be 2h minus 3x. Okay, so when you expand, it's going to get 6h minus plus k. Okay, so this is your fgx. Now you're going to find the next one, which is gfx. So gfx is going to be equals to g, and then the object is what? Is fx, right? So you got g is 2h minus 3x. But in this case, you're not going to substitute. The object is not going to be x. The object is going to be fx, which is 3x plus k. So let's expand this. You will get 2h minus 9x minus 3k. Okay, so now you can use this equation. They said fg is equals to gf. So let's substitute. 6h minus 9x plus k is equals to 2h minus 9x minus 3k. So these two of these are the same, right? So you can actually neutralize it, becomes 0, okay? Because when you shift, it becomes plus, so you still get 0. So now let's shift the h and the k. So 6h minus 2h, and then here will be negative 3k minus k. 6 minus 2, 4h, here become negative 4k. So h is equals to negative k. So this is the relationship, right? Let's look at the next question. For each of the following function, find the value of the object x. So in this question, right, they gave you fx, the equation, they gave you gx, another equation, and they also gave you the composite function, okay? And you are supposed to find the x value, which is the object. Okay, so let's solve this. So fx is this, and they give you gf, so you have to find what is gf. So gf is actually equals to, you're substituting gx as the object of f. So what is f? F is 2x minus 5. But in this case, you're not going to use x, you're going to use gx. So what is gx? 10 over x. Okay, so when you expand, it's going to become 20 over x minus 5. So they already gave you that gx is equals to 5. So this is going to be equals to 5. So 5 plus 5, you get 10 equals to 20x over x. And x is going to be equals to 20 over 10, which is 2. Okay, so that is the value of x. Next, let's look at question B. They're giving you gx this time. So gf is equals to substituting fx as the object for gx. So gx is 2x plus 1. But now instead of substituting x, it's going to be fx, so which is x squared minus 1. Okay, so you're going to expand this and you will get 2x squared minus 2 plus 1. So 2x squared minus 1 is equals to 7, right? Because they gave you here gfx is equals to 7. So 7 plus 1 is 8, is equals to 2x squared. So x squared is equals to 4, and x is equals to plus minus square root of 4, which is plus minus 2. Okay, so you have two possible answers, positive 2 and negative 2, right? Next, given the function f and the composite function fg, determine the function g for each of the following. Okay, so this is actually pretty straightforward, right? It's actually the same concept. I want you to apply the same concept as the previous questions. So it's going to be, let's see A. So they gave you fg, correct? fg x is equals to 2x squared minus 4x plus 7. So what did I tell you? So fgx represents, the object is now gx. You're going to substitute gx into f. But now the question is, they didn't give you what is g. They expect you to find the value of gx, but they gave you the value of fx. The equation is what? X minus 3. So it's going to be x minus 3 equals to 2x square minus 4x plus 7. But the difference is, you're not substituting x, you're substituting what? Gx. So you have to change this to gx. Okay, so you just have to shift everything and you will get your gx. So gx is equals to 2x squared minus 4x plus 7 plus 3. So it's equals to 2x squared minus 4x plus 10. This is your gx. Let's look at the next question. Fx is x squared plus 1, and they gave you fgx. Okay, so same thing. They want you to find gx. So fgx equals to x squared plus 4x plus 5. So now they didn't give you, they want you to find gx, so you have to substitute gx into fx. So fx is what? Fx is x squared plus 1 equals to x squared plus 4x plus 5. But this time, you're not going to substitute x, you're substituting gx. So it's going to be gx square, right? Because the fx here, there is square here, right? So gx square plus 1 is equals to x squared plus 4x plus 5. So you're going to shift this. You get x squared plus 4x plus 5 minus 1. So gx is equals to x squared plus 4x plus 4, and it's going to be square root. Okay, so if you use your calculator, you can actually factorize this. Okay, when you factorize, you should get x plus 2 square. Okay, so because you get a square root and a square, you can cut it off and you should get x plus 2. So this is your gx, right? Next, given the function f and the composite function gf, determine the function g for each of the following. So this question is similar to the previous question, but this one is a little bit more tricky, right? I want you guys to pay attention, right? How you're going to solve this. So on a previous question, they gave you, for example, let's say they gave you gfx, okay? They gave you gx and they didn't give you fx, right? So what you can do is you can just substitute fx into gx because they gave you the value of gx. But in this case, it is the opposite. They did not give you they did not give you gx. They leave this empty. You don't have gx. So it's not possible for you to substitute fx into gx because you don't know what is a gx. Okay, so because of that, I want you guys to understand this concept. When you ever encounter questions like this, the only way for you to solve is, since gx is not given to you and you're looking for gx, so what you're going to do is you're going to neutralize this. You're going to neutralize this. How you're going to neutralize? By substituting an inverse of f. So what is it going to, it's going to become like this: g f inverse x. Okay, so why am I doing this? Because when I do this, essentially I'm neutralizing the function. So I'm neutralizing this, it becomes g x. Okay, I'm neutralizing the fx so that it becomes x. So you get gx. So this is the answer that you are looking for. Okay, so remember this special case, alright? If the gx is not given to you, which is the function on the left, if the function on the left is not given to you, you cannot substitute this into the function on the left because it's not given to you. So what you're going to do is you're going to neutralize the f. In this case is fx, so you're going to neutralize it with f inverse x. So I'm going to show you how to find f inverse x. Okay, so bear with me. Now you understand how to solve this, right? You just have to follow the steps. So in this case, you're going to put you're looking for gf f inverse x. But what is f inverse x? Now I'm going to show you how to get. So you know that fx is x plus 1. Okay, so to inverse this, first thing, you're going to change this fx value, change it in terms of y, make it y. Okay, substitute as y. So you're going to assume fx equals to y. So y is equals to x plus 1. Okay, now you're going to shift everything on the right to the left, okay, except the x value. So you are left with y minus 1 equals to x. Okay, so this, my friend, this is the f inverse value, right? This is the f inverse value. So it's going to become y minus 1 equals to f inverse y. Why is it y? Because your equation is in terms of y. So that's why here is still y. If you want to change it to x, you just change it to x minus 1 equals to f inverse x. Okay, so this, my friend, is how you get f inverse. Now you have to substitute into this equation. So you know that this is equals to gf and f inverse, right? So you already have the gx value, gf equation. So it's going to be x square minus 2x minus 3. But this time you're not going to substitute x, you're going to substitute what? F inverse. So it's going to be x minus 1 square and x minus 1. Okay, so you expand, is going to become x square minus 2x plus 1 minus 2x plus 2 minus 3. So x square remains, you got minus 2x, so you get minus 4x plus 1 plus 2, so you get 3 minus 3, so you get 0. So you get x square minus 4x. So your gx, once you have neutralized, you have gx now, is equals to x square minus 4x. Okay, now let's look at b. So b, they gave you same thing, they gave you fx and gfx. They want you to find what? They want you to find gx. Okay, so since you cannot substitute because you don't know what is g, so you have to neutralize it using this. You're going to neutralize this. It's f inverse x. Okay, so first thing, have to find your f inverse. So fx equals to x square plus 3. Now you're going to make this equals in terms of equals to y. So fx equals to y. So y equals to x square plus 3. Now shift everything to the left. So y minus 3 and square root, you should get x. Okay, so this is your function of your inverse function, inverse of f inverse y. So if you want f in terms of x, it's going to be square root x minus 3. Okay, now you already found your f inverse, so you're going to substitute into gf. So gf is 2x square plus 3, but x square is what? X is no longer x, it's actually square root x minus 3 square. Okay, so when you solve this, you get 2. See here is square and here is square root, so you can cut it off. You get x minus 3 plus 3. So you get 2x minus 6 plus 3. You get 2x minus 3. This is your answer. Right, next. The function f is defined by fx equals to x over x plus 1. Find the iterated function. Okay, so they want you to find f2, f3 and f4. So f2, like I said, is equals to what? ff. Correct? So you just have to substitute the fx value into itself, which is another fx. So x plus 1, but now the x is going to be x over x plus 1, x over x plus 1. So what do you get? X over x plus 1 over, so it's going to be, you're going to make this 1 over 1, so it's going to become x over x plus 1 plus x plus 1, x plus 1. Okay, so it becomes x over x plus 1 over x plus 1 over x plus 1. I know it's getting a little bit complicated, but just bear with me, okay? X over x plus 1. Since in this case is divide, so I'm going to change it times it becomes x plus 1 over 2x plus 1. So this one you can cut, you should get x over 2x plus 1. So this is f2. What about f3? Well, f3 is equals to f2 and you substitute the another fx, so you get f3, correct? So what is fx again? F square is going to be equals to x over 2x plus 1. Okay, but in this case you cannot use x, you have to substitute fx, so it's going to be x over x plus 1, x over x plus 1. So you get x over x plus 1 over 2x over x plus 1 plus x plus 1 over x plus 1. So x over x plus 1 times, okay, I'm going to change it to times, so you get x plus 1 over 2x plus x is 3x plus 1. Now I hope you guys understand I'm doing it a lot faster now, so that, I mean, we can go through it faster. So x plus 1, you can cut, you get x over 3x plus 1. Okay, lastly, they ask about f4. So f4 is equals to f3 and fx. Okay, so fx is equals to x over 3x plus 1. So what is the x value? Well, x value is actually the fx value, x over x plus 1, x over x plus 1. So how do you solve this? You can expand, you get x over x plus 1 over 3x over x plus 1 plus x plus 1 over x plus 1. So x over x plus 1 equals to, not equals, times x plus 1 over 3x plus x equals 4x plus 1. Cut x over 4x plus 1. Okay, so yeah, so you notice something is that, one thing you notice is that when it is f square, you get 2x here. Okay, when it's x cubed, you get 3x. When it's x4, you get 4x, and the others are the same, x plus 1, x plus 1, x plus 1. So the only thing that is changing is when it's x power 2, you get 2x, x power 3, you get 3x, x power 4, you get 4x. The reason why you want to know that is because you see question B. Hence, write the function f20 and f23. Right? You cannot be counting all the way to f20. So for you to solve this, you have to understand the relationship between this and this. Alright? So in this case, since you know that the only thing that is changing is this, correct? The only thing that is changing is this. So for you to solve this, I'm just going to write it here because it's actually very straightforward. So f20x is actually equals to x over 20x plus 1. Right? And f23 is equals to what? X over 23x plus 1. Right? It's that simple. Right? So let's see the next question. The surface of a hot air balloon A filled with hot air is given by the function AR 4 pi r square, okay, where r is the radius of the balloon. The radius of the balloon is increasing as a function of time according to the formula r equals to 2 over 3 t cubed. Okay, so they're given you the surface area function, okay, but this is in terms of r, that's why it's AR, okay, so in terms of r. And then they tell you the radius is increasing, right? The radius is what they say, increasing as a function of time, so based on time. So the longer the time, the radius is going to increase. So they gave you RT because it's in terms of time. So now the question is, state the surface area of the balloon A, okay, the surface area, as a function of time. So instead of in terms of R, which they originally given you, they want in terms of time. So for you to put in terms of time, you have to make RT as the object. Why? Because RT is the radius, but this is already in terms of time. So you have to make RT a subject, an object of A. So in other words, you're substituting RT into A. So you know that A is, the area is 4 pi R square. Okay, but you can't use R because you want in terms of T. So you substitute RT, which is 2 over 3 T cubed. And you're going to square this, okay? So here it becomes 4 pi. So the bracket here, when I square this, it's going to become 4 over 9 T 6. Yeah, 3 times 2 is 6, correct. So 4 over 9 T6. So when you multiply, it becomes 16 over 9 pi T power 6. Okay, so this is your answer in terms of T, correct? Next, find the surface area of the balloon after 2 seconds. So they gave you the time, right? So this equation that you have here, it's actually what? AT, right? Because it's in terms of time. So this is 16 over 9 pi T6. Okay, so now they give you the value of time. They want you to find the surface area. So A, what's the object now? 2, right? Because it's 2 seconds. So it's 16 over 9 pi times 2 power 6. So you can use your calculator. I'm just going to give you the answer straight. It's going to be 113.7 over 9 pi. Now what's the unit for this? The unit is going to be meter square because it's area. Okay, same thing applies here. It's going to be meter square. Okay, so a cylindrical container of radius 20 cm contains 200 cm cube of water. Okay, so you got a cylindrical container. Okay, you got a cylindrical container. The radius is 20 cm, and then they're saying that the volume, initial volume, is 200 cm cube of water. Okay, so the container is filled with water. Oh, okay, they're filling it with water at a constant rate of 100 cm cube per second. Okay, so you know that the first volume, initial volume, put here V1, is equals to 200. Okay, so you have 200 cm cube, and as you add water in to the container, the rate is what? So V over T is equals to 100 cm cube. Why did I write this? Because you notice that it says here cm cube per second. So cm cube per second. What does this mean? Cm cube means volume, per means divide, second means time, right? So they're actually giving you the hint. They're telling you how is the formula like. Okay, so V over T equals to 100 cm cube per second. So the question here asking, number 1, find the amount of water in the container after T seconds. So you know that the initial volume is 200. Okay, so it's already in the container, and on top of that, it is constantly increasing. So what is the V? Let's say I write here V2. Okay, so V2 is equals to 100 times T, correct? So it means that as time passes, the volume is going to keep increasing. Okay, so that is why if they ask for the amount of water in a container, you have to put the initial amount, which is 200, plus the amount that is being filled in the container. So this is your answer. This is in terms of volume, so cm cube. Okay, next, number 2, the height of water in the container, H in terms of V. So since this is a cylinder, like cylindrical container, so it's a cylinder, So what's the formula of cylinder? So volume of cylinder is equals to pi r square times the h. Okay, pi r square h. So now you want to find in terms of you want to make h as a subject. So h is equals to v over pi r square. So this is your equation. But now they said in terms of v. So you only want in terms of v. So you want to remove r. So what is r? R is given to you 20 cm. So h equals to v over 20 square pi. So it's equals to v over 400 pi. Okay, so this is your h. So height should be in cm as well. Okay, now number 3, the composite function of hvt. Okay, so you notice that they ask for hvt. So do you have vt there? Vt is this, right? It's the volume in terms of time. So you have vt. And do you have h there? You just found h, correct? This is your h value. So now they want you to substitute vt into h, right? So it's actually pretty straightforward. Once you have these two equations, it becomes very straightforward. So h is equals to v over 400 pi. But since you're substituting v, so what is your v value? Your v value is 200 plus 100t, right? So when you substitute, now you can simplify this. So you're going to factorize 100 out of the equation. You get 2 plus t over 400 pi. So you can simplify this. You get 2 plus t, here is 4, right? So it's 4 pi. Okay, so this is your hvt. Okay, actually it's the same as ht because it's just the equation of h but in terms of time. So ht, you can also write it that way. Okay, now b, find the height of water in the container after 20 seconds. So they gave you the time, they want you to find the height. So I said this now ht, right? Because in terms of time. But now the time they gave you is 20 seconds. So h20 equals to 2 plus 20 over 4 pi, right? Using back this equation. Okay, so you get 22 over 4 pi. You can leave your answer like this, or you can calculate in terms of decimal. So you just use the unit, right? Make sure you put the unit, or you can write, if you count in terms of decimal, you should get 1.75 cm. Okay, so these are your answers. Alright, so we have covered all of this subtopic using the examples just now. So I hope you guys learned something from this video, and I'll catch you guys on my next video. Alright, see you, take care.